Hey, Chem Kids, Campbell here. In this video, we're going to talk about metric conversions. You've probably noticed that in all your science classes, you use the metric system, and that will be the same in chemistry. We use it because it's a multiple of 10, which makes it easier than, say, our English system, where we're going between, I don't know, ounces and cups, and who knows what, 16? No, that's in a, so yeah, I don't know. But a multiple of 10, hey, that's easy. We also use it because it's the international system of units, which means pretty much everybody else uses them except for here in America. And those are called the SI units. So one of the things you need to know is what is the SI base unit for each of the measurements that we're going to make. So the one that's bizarre is the mass. Mass is actually a kilogram, which is a prefix with a base unit, you would think, right? And that kind of confuses people because the actual SI unit of mass is the kilogram. But when we go to our number line on the next page, we're going to call the gram that base unit that goes for our prefixes, because kilo is actually a prefix. So we're going to talk more about that in class because it's a base unit, but it's not. So mass is a kilogram, length is a meter, time is seconds, amount of a substance is a mole, and we're going to talk about that later in the semester. Temperature is Kelvin, believe it or not, but in lab we always work with Celsius, and we're going to keep our stuff in Celsius when we work in the lab. It's not until we get to the gas law unit where we're going to have to work with Kelvin, so we'll talk about that later. The SI base unit for volume is actually the centimeter cubed, but in lab and typically we do volumes in liters. So our liter is going to be our base unit on our number scale, but the actual SI base unit is the centimeter cubed. All right, let's make this prefix scale because we're going to use this whether we do conversions by moving the decimal or we do conversions by dimensional analysis. So I want you to fill this out. Now remember, the metric system is a multiple of 10. So first we're going to look at going up the scale. So getting bigger than the base unit. There's deca and hecta and kilo. Kilo's a big one. Go up 3 lines to mega and another 3 lines to giga. So those are the units that are bigger than the base unit. The units that are smaller are the deci, the centi, the milli, then go 3 more to the micro, and 3 more to the nano. Now, the ones that are in bold here, you need to know. And our base unit here, the thing in the very middle, that's going to be like the gram, which is on this, the base unit. The SI base unit is the kilogram. It's the liter, it's the meter. Those are the things that are our base units. Now, the abbreviations we typically use when we're doing these. So if you see something that's kg, right, that's kilogram. Or if you see a capital D with a little m, that's decameter. Or a little d with an m, decimeter. So make sure you know the abbreviations. The other thing I want you to write down is the multiplier for the base unit. So that's how many base units are in that prefix. So remember I said they're multiples of 10, so each of these slashes is a 10 or a multiple of 10. So as we go up, right, here's our 10, and then we have 100 and 1,000. So a kilo, there's 1,000, say, grams or 1,000 base units in a kilo of that base unit. 10 to the 6th for mega and 10 to the 9th for giga. And then on our other side, it's smaller. So deci is smaller. It's smaller by 0.1. A centi, 0.01. So a centimeter, there's actually 0.01 meters in a centimeter. The thousandths place is the milli. So that's 0.001 times 3 more zeros, and we get a micro, 10 to the negative 6th, and nano, 10 to the negative 9th. Now, it's very important that you remember this cluster in the middle. And one way to do that is something I'm sure you probably learned in middle school. King Henry died by drinking chocolate milk. Now, there are other ones that you can use. This is the one I've heard the most often. And each of those represent one of the prefixes, and the B for by is the base unit. So if you remember, King Henry died by chocolate milk, and there, like I said, there's others, something about a mouse or a cat or something, I don't remember. But that's the one I remember. It helps you keep those base units in the proper place of how far they are, or those prefixes in the proper place for how far they are. Now, we need to learn how to convert between them. So Let's look at moving the decimal place first. So in the decimal place movement method, you find the unit you're given on the number line. Then you're going to move the decimal the number of places and in the direction that you're moving on the number line until you reach the unit you're converting to. So let's do this. For example, if I have 4.5 kilograms and I want to go to grams, so a kilogram is right here. If I want to go to grams, that means I need to move the decimal place 1, 2, 3 places to get me to there. So let me write this up here so it's easier for me to move the decimal. So that means I'm going to go 1, 2, 3, and I'm going to move the decimal here and fill this in with zeros. So that makes this 4,500. I moved that decimal over 3 places because that's how far, and I moved it to the right because that's where I have to go to get to the base unit. What about 5 millimeters to a kilometer? Whoa, that means I'm starting down here at the milli and I need to go all the way up to here. So I got to move 1, 2, 3, 4, 5, 6 places to the left. All right, let's do that. 1, 2, 3, 4, 5, 6 places to the left. Fill the rest in with zeros. And what do we get there? We get a 0.00005 kilometers in 5 millimeters. Woo, that's a tiny number. So the method, if you remember the King Henry died by drinking chocolate milk, then you just move the number of spaces and in the direction. That's all you're doing with the decimal place. It makes it a lot easier to do unit conversions. However, sometimes dimensional analysis is a good way to go about it. And the reason why I bring this up is because if you take a class like physics and you're doing conversions between seconds and days and hours, then dimensional analysis is a good way to go. So if we use dimensional analysis, what we do is we multiply by what I call the base unit multiplier, that thing I gave you on the top of the number line. So for example, if I want to go 4.5 kilograms to grams, remember that it's 1,000 grams in a kilogram. There is the 1,000 sitting on the top of the number line. So that means I need to take the 4.5 and I multiply by 1,000 grams per kilogram. We set the ratio up like this because in dimensional analysis, we set up with fractions. These will cancel each other out because they're above each other. It's like putting 1 over 1, right? That's just 1. Or 2 over 2, right? Those cancel and just become 1. So here, those units cancel out and leave me in grams. So if I multiply 4.5 by 1,000, I get 4,500 grams, which is what I did when I used the number line method. Or if I go 5 millimeters to meters. So if you go to the little number line above millimeters, you'll see it's 0.001. So I'm going to take my 5 millimeters and I'm going to multiply by that multiplier, 0.001 meters per 1 millimeter. So when I do that, millimeters cancels out and I end up with 0.005 meters. Or I could have just moved the decimal over 3 places to get to meters. Now, if we go from base units, if we're starting in the base unit and we're going to a prefix, then we have to flip that fraction. So for example, if I start with 2.5 meters and I want to go to centimeters, what I need to do when I go to that number line, I see it's 0.01 meters per centimeter. So if I flip the fraction, now it's very important that the units are one's on top and one's on the bottom so they cancel. So that means I'm going to take 2.5 and I'm going to divide by 0.01 and that gives me 250 centimeters. Or I go to the number line and I go meter, decimeter, centimeter, move it over 2 to the right. It's probably easier. Now, if we have to go from like the milliliters to the kiloliters, like we did with moving the number 6 places, then we have to set up 2 little fractions. We got to go to the base. So we got to multiply by the 0.001 liter per milliliter. And then we need to multiply by the base to that prefix, the kiloliter. So remember, it's 1,000 liters or 1,000 base units per kilo. So I flip that fraction. And so I take 7.5 and I multiply by 0.001. That gets rid of milliliters and puts me in liters. And then I divide by 1,000, because then I can cancel out my liters, and I'm left in a kiloliter. So 7.5 times 0.001 divided by 1,000 gives me a whole heck of a lot of zeros. 5 zeros. Is that 5 zeros? Or I could just move the decimal over 5 places, or 6 places, right? 6 places away. Either way, whatever works for you, that's great. All right, I want you to do some practice. But one of the things I want you to think about when you're doing practice is if the unit is getting bigger, so we're going up that number scale from a base unit to a liter, a base unit to like a kilo. If the unit is getting bigger, the number gets smaller. So if I had a meter and I'm going to a bigger unit, I get a smaller number. So if I'm going up, the number goes down. Or if the unit's getting smaller, like say I'm going to a millimeter, then the number gets bigger. So if the unit goes down, the number goes up. They're like opposites of each other. So maybe that'll help you. Hey, I'm going to a smaller unit, that should have been a bigger number then. So you try these, pause the video, try them, and see what you get. Did you get them correct? We'll work on some more of these in class together. See you in class.